Okay, class, we're about to start lesson 4, fraction operations. And we're going to deal with addition and subtraction of fractions. Now, I'm going to skip through all of this and we're going to go directly to the problems. And I will explain how to solve them as we go along. Okay, so first of all, in order to add or subtract fractions, they must have the same denominator, or as we say, the same bottom. If they do not have the same bottom, you cannot combine them. We will have to find that same denominator or bottom. And then also, if your final answer ends up being an improper fraction, you must write your final answer as a mixed number. So let's go through this and start off with problem number 1. We have 3/8 plus 1/8. Okay, now, first thing we check for with addition. Well, first, let's read the directions. This says solve. Reduce answers to lowest terms. Simplify improper fractions as mixed numbers. Okay, so now we look here. We see that as addition. So we look at the bottoms or the denominators. They're the same. So that means we can add them in their present form. So first thing you do with that denominator, you bring it down as is. You do not add or subtract your denominators. When they're the same, you just bring them down. Matter of fact, I will go on to say you never add or subtract your denominators, whether they're the same or not. So you bring down this denominator, which is 8. And then now you just add the numerator. 3 plus 1 is 4. Now 4/8, we know we could simplify that by dividing by 4/4, which would be 1/2. So your final answer here would be 1/2. Okay, now let me do a subtraction problem, and then we will get to the problems where the numbers are different. So number 3, we had 8/9 minus 5/9. Our denominators are the same and it's subtraction. So we bring down our denominator. And now we subtract our numerators. 8 minus 5 is 3. So 3/9. 3 and 9 both has 3 in common. We divide both by 3 and it'll be 1/3. Okay, now we go to some problems where the denominators are not the same. So let's take a look at problem number 5. For problem number 5, we have 1/4 plus 2/3. Now, we first look and see as addition, but we also notice that their denominators are not the same. So what we would do, we have to figure out what number do they have in common to get a common denominator. So we look at 3 and 4. Now I said this in class, so I'm going to say this on the video. The lowest number that they would have in common for a common denominator would be the larger of the two. So the larger of 3 and 4 is 4. So the lowest possible number they could have for a denominator would be 4. But we know 3 does not go into 4. So our denominator would be higher than this 4. So that means that when we look at these denominators, whatever the higher number is, it could be that number or higher. That's only if both numbers go into it. Now, the number that both of these have in common is 12. So what we would do here on the other side, we would make our denominators 12. And we would ask ourselves, 3 times what gives us 12? It'll be 4. So you have to multiply this numerator by 4. Then we ask ourselves 4 times what will give us 12? It'll be 3, and you multiply this numerator by 3. So we multiply at the top. 1 times 3 is 3. 2 times 4 is 8. So now we have a common denominator of 12. We bring the 12 down, and we add the numerators. 3 plus 8 is 11. So that's 11/12. Okay, now that took care of problem number 5. Now I want to go on to a subtraction problem because it's the same process. So we're going to go to number 7. Number 7, we had 9/10 minus 3/5. We notice our denominators are not the same in the subtraction. So we ask ourselves, what is the common denominator of 5 and 10? It's 10. 5 goes into 10 and 10 goes into 10. So our common denominator would be 10. So we ask ourselves, 5 times what is 10 is 2. So we multiply the top and bottom by 2. And then here 10 times 1 is 10. And 9 times, and we'll multiply by 1 over 1. So 5 times 2 is 10. 3 times 2 is 6. 10 times 1 is 10. And 9 times 1 is 9. So 9/10 minus 6/10, we have our denominator of 10. 9 minus 6 is 3. So it's 3/10. Okay, now I want to do two more of these fractions with different denominators, and then we're going to go on to the mixed numbers. So let's look at problem number 6. So we will have 1/2 plus 5/8. Now the common denominator of 2 and 8 is 8. So we know 8 times 1 is 8, and we'll multiply the numerator by 1. 2 times 4 is 8, and we'll multiply the numerator by 4. 8 times 1 is 8, 5 times 1 is 5. 2 times 4 is 8, and 1 times 4 is 4. So we'll bring down this denominator of 8. We'll add the numerator. 4 plus 5 is 9. Now we have an improper fraction. We can't leave it like this. And then before we make this into a mixed number, 9 and 8 only has 1 in common, so we don't have to simplify it. So we'll take 8 into 9. 8 goes into 9 once. 1 times 8 is 8. 9 minus 8 is 1, so you have a remainder of 1. So our final answer, the number that's in front of the remainder, is your whole number. Your denominator remains 8, and your numerator is your remainder. So it's 1 and 1/8. Okay, now we're going to move on to problem number 8. Problem number 8, we have 7/9 minus 1/2. Common denominator of 2 and 9 would be 18. So we know 2 times 9 is 18, so we'll multiply this 1/2 by 9 over 9. And 9 times 2 is 18, so we'll multiply this fraction by 2 over 2. 2 times 9 is 18, 1 times 9 is 9. 9 times 2 is 18, and 7 times 2 is 14. We'll bring down our 18. 14 minus 9 is 5. So it'll be 5 over 18. Okay, so now we've solved fractions that had different denominators. We've solved fractions that had the same denominator. Now we're going to deal with mixed numbers. So what I want to do, I want to look at let me do problem 9 for right now. So we have 2 and 1/5 plus 1 and 2/3. Now the first thing I would suggest is when you're doing a mixed number and you notice the fractions have different denominators, we start addressing the fraction first before we deal with the whole numbers of the mixed number. So we can act like the whole numbers are not there. What is the common denominator of 3 and 5? It's 15. So we know our denominator would be 15. Now we would carry over our whole numbers. We'll still carry them over. But we know we're getting 15 for our denominators. So 3 times 5 we know gives us 15, so we multiply by 5 over 5. 5 times 3 gives us 15, so we multiply by 3 over 3. 3 times 5 is 15, 2 times 5 is 10. 5 times 3 is 15, and 1 times 3 is 3. So 3 15s plus 10 15s will bring down our 15s, and 3 and 10 is 13. 2 plus 1 is 3, and nothing more can be done with this problem. All right, now we move on to problem number 10. Problem 10, we have 4.5 minus 2 3/4. Now, again, we notice our fractions don't have the same denominator, so we have to find a common denominator, which would be 4 here. So we know we carry over our whole numbers, and we'll bring over our new denominator of 4. So we know this fraction will be multiplied by 1 over 1 because you already have 4 here, and this fraction will be multiplied by 2 over 2. So this would be 4 times 1 is 4, 3 times 1 is 3, 2 times 2 is 4, and 1 times 2 is 2. Now, I like this problem because we also encounter another issue here. We cannot subtract 3/4 from 2/4, so we actually have to borrow in this problem. So now, just like we did with regular subtraction, when we borrow 1, that lowers that whole number by 1. Now, before we use that 1 we borrowed, I'm going to show you what all you carry over first. So let's carry over everything before we utilize the 1 we borrowed. We'll bring over our 2 3/4. We'll bring over our 3 now. Our denominator still would be 4. Okay, so let's recap. We borrowed 1, but that brought over the 3. Our denominator still carried over. All of this bottom portion still carried over. So we have all of that. So the only thing now that we're concentrating on is what is going to be that new numerator. Now I'm going to tell you how to figure out that new numerator. All you have to do is go back to this fraction here where you borrowed from, this fraction. You would take the denominator and add the numerator. What's 4 plus 2? That's 6. So that's how you get the new numerator. You take that denominator and add it to the numerator to get the new numerator. That's only when you borrow. Again, that's only when you borrow. Now we can subtract. You bring down your 4. 6 minus 3 is 3. 3 minus 2 is 1. That is your final answer, 1 3/4. Now, it's not much more that we need to go over here. It's like maybe uh, 2 more problems that we need to go over from problems 11 to 25. And the first one we'll go over is those mixed numbers that have 3 of them. And you'll basically do that even if you had like 3 regular fractions. You would do it the same way that I'm about to do problem number 18. So problem 18, we have 10.5, we have 8 4/5, and we have 3 1/4. Okay, now we start this off the same as we did the other problems where we had mixed numbers that had different denominators. We find a common denominator. The common denominator of 2, 5, and 4 is 20. So the common denominator is 20. So what we will do, we'll carry over all of our whole numbers and the common denominator, which is 20. So we say 4 times what is 20? We know this will be 5 over 5. 5 times 4 is 20, so this will be 4 over 4. And then 2 times 10 is 20, and this will be 10 over 10. So now we multiply 4 times 5 is 20, 1 times 5 is 5. 5 times 4 is 20, 4 times 4 is 16. 2 times 10 is 20, and 1 times 10 is 10. So now we bring down our 20, and we add our numerators. 10 and 16 is 26, plus 5 is 31. 10 plus 8 is 18, plus 3 is 21. Okay, now we notice here that we have an improper fraction for our fraction here. But first, let's see if we can simplify. 31 and 20 has nothing in common, so it's already simplified. So what we need to do here is change this improper fraction to a mixed number and add it to this number here. Okay, so we're going to go off to the side and take 20 into 31. 20 goes into 31 once, and that will leave us with a remainder of 11. Okay, so this right here is 1. Our denominator stays 20, and this is 11. Okay, now let me tell you what you do with this. Once you get here, this 31 over 20 is no longer relevant. This replaces that 31 over 20. So this is how you would go about doing this. You would take this 21 and you would add it to this whole number. So, and I'll write that out. Again, 21 plus this whole number. So you're going to say 21 plus 1 is 22. And I'll draw a line showing where these numbers came from. This 1, I'll get all the way up there. This 1 came from here. This 21 came from here. That gave you 22. Now for the fraction that you would have. Whatever fraction you have here will be your fraction here. So this is your final answer. 22, 11 over 20. Now that's 18. Now we're going to go to problem number 20. Now, if you're having issues with this, you could rewind this and rewatch 18 and see it done all over again. 20. I'm going to line this up. We have 15 minus 3 and 7/8. Okay, now if you notice here, we have this whole number 15 minus 3 and 7/8. We cannot subtract 7/8 from nothing. So we have to borrow 1 from this 15 and make it 14. So now let's carry over everything that we have. This minus 3 and 7/8 and a 14. Now we have to use that 1 we borrowed. Now this is what I'm going to tell you. The 1 that you borrowed, this is how you write it. You look at the denominator of the fraction that you still have in play here, which is 8. Whatever that denominator is what that 1 is going to be that you borrowed. So remember, you borrowed 1. The 1 you borrowed is going to be 8 over 8. Now, if this denominator was 9, it would be 9 over 9. If this denominator was 10, it would be 10 over 10. Okay? And the reason being is, remember, we're trying to subtract. So if we're trying to subtract, we want the denominators to be the same. So that is why we convert that 1 to have the same denominator as the fraction we have. So 8/8 minus 7/8, we'll bring down our 8. 8 minus 7 is 1. And 14 minus 3 is 11. And that's your answer for problem 20. Now, I did talk about this in class. What if, this could be like an example 1. What if you have 15 and 7/8 minus 3? What if you had the mixed number up top and a whole number at the bottom? If the mixed number is at top, you could just bring down the fraction and then subtract the whole numbers. So that'll be 12 and 7/8. But you see the difference. This is up top. So we know, just like we do regular fractions, you can have a number up top like 9 and 0. You could just subtract 9 minus 0 and you're good. But if you had the 9 at the bottom and the 0 at the top, you have to get the borrowing. So that's just an example for you. Okay, now let's look at, it says problem 26. Well, it says choose the one best answer to each question. All right, so this is for problems 26 to 29. So I'm going to do problem 28. It says, at a fabric store, Melissa sold 8 7/8 yards of cloth to a customer. If the material was cut from a bolt of fabric containing 23 1/4 yards, how many yards are left on the bolt? So basically, we're doing a subtraction problem here because we're trying to find out how much is left. So we had 28, we had 23 1/4 minus 8 7/8. Now remember, we have to find that common denominator, and our common denominator here would be 8. So we'll carry over what we have, so it'd be 23, and our denominator would be 8. Now, we say 8 times what gives us 8? We'll know we'll multiply that by 1/1. And then 4 times 2 is 8, so we'll multiply this fraction by 2/2. So 8 times 1 is 8, 7 times 1 is 7. 4 times 2 is 8, and 1 times 2 is 2. Now, we could not subtract 7/8 from 2/8, so we will borrow. So we'll borrow 1 from this 23 and make it 22. And we'll carry over all that we have so far. Now, to get our new numerator, we'll take this bottom number plus the top number, because remember, we have to account for the 1 we took out. 8 plus 2 is 10. So now we subtract. Our denominator is 8. 10 minus 7 is 3. And 22 minus 8 is 14. So it's 14 3/8. Okay, 29. A batch of salad dressing requires 1 2/3 cups of olive oil, a half cup of vinegar, and 3/4 cup of water. How many cups of salad dressing will this recipe produce? Okay, so now it's basically an addition of mixed numbers. So again, we have 1 2/3, we have 1/2, and 3/4. So we look here, we notice we don't have a common denominator, so we have to find a common denominator of all 3 of these fractions. 4, 2, and 3, the common denominator is 12. So we only have one whole number, so we'll carry over that whole number, and then the rest we'll carry over our denominator of 12. So we know we'll multiply this one by 3/3, this by 6/6, and this by 4/4. So this would be 8/12, this would be 6/12, and this would be 9/12. Bring down our 12. 8 and 6 is 14, plus 9 is 23. And then 1 plus is no other whole number, so we'll bring down our 1. So now we have 1 and 23/12. So this is an improper fraction. First, we see if we can simplify it. It's already simplified. So we go off to the side and we take 12 into 23. 12 goes into 23 once. 23 minus 12 is actually 11, so we have a remainder of 11. So our answer here is 1 11/12 from this improper fraction. So now that we have the 1 11/12, we know this 23/12 does not matter anymore. All we have to deal with is this 1 1/12. So what we would do, we would add 1 plus 1, this 1 coming from here, and this 1 coming from here. We would add those two together, and that gave us 2. And we would take this fraction, and that would give us 2 11/12. And that is our final answer. And that answer would be, what's that, C? And then in the previous problem, I didn't write down that this answer was A. All right, so we are done. This is the first half of dealing with fractions. This is with addition and subtraction. The next half, we would do it with multiplication and division. So I will get this other half on YouTube as well.